Imagine for a second that you've lived your entire life inside a movie theater.
Okay, a movie theater. I'm with you.
Right, but you are physically restrained. Like you're only allowed to look straight forward at the screen.
Oh, wow. Okay, so very Plato's cave.
Exactly like Plato's cave.
Yeah.
So you're looking forward and you see these vibrant, moving shapes, just two-dimensional shadows flickering, interacting, appearing, disappearing.
Right.
And over the decades, you and the other people in the theater, you build these incredibly complex mathematical models to predict exactly how those 2D shadows will behave.
Because that's your whole universe.
Exactly. And your math gets practically perfect. I mean, you can predict every collision, every single flash of light on that canvas.
You've mastered the shadows.
Right. But then somebody just taps you on the shoulder, points up to the projection booth behind you, and says, none of that is actually physical reality, right?
Oh, man.
Yeah. They tell you you've just been studying the two-dimensional shadow of a three-dimensional hologram this whole time.
I mean, that is an incredibly disorienting proposition to hit someone with.
Totally.
Because you're basically being asked to throw out the fundamental bedrock of your entire worldview.
Right.
The rules you built over centuries, I mean, they aren't necessarily wrong for describing the screen itself.
Sure, the math works for the screen.
Right, but they are entirely structurally useless for understanding the actual machine that's projecting the movie.
And that right there is exactly where we find ourselves today in physics.
It really is.
We are asking you to look up at the projector. Welcome to today's deep dive. We are unpacking a genuinely paradigm-shifting paper.
A total game changer.
Yeah, it's from 2026 by the physicist George James Dukas, and it's titled The Misconception of Quantum Physics and the Failure of Unification.
It's quite a title.
It is not pulling any punches. So what we're going to do here is completely deconstruct the physical reality that you think you know.
Yeah, buckle up.
We are looking at this rigorous, no-holds-barred critique of a really major recent physics program out of MIT. And along with that, we're diving into the introduction of a new framework.
Right, the Transdimensional Unified Field Theory, or TDUFT for short.
TDUFT. I like that. So to really grasp the gravity of what Dukas is arguing here, I mean, we need some context, right?
Yeah, absolutely. We have to look at the holy grail of modern physics for the last 100 years.
The theory of everything.
Exactly. The theory of everything. Because for decades, physicists have just been tormented by the fact that our universe seems to have a severe split personality.
Right. It's like two different universes living in the same house.
Exactly. On one hand, you have classical mechanics, Einstein's general relativity.
Big stuff.
The physics of the very big. Galaxies swirling, planets orbiting, apples falling from branches.
Right. It's all very predictable.
It is. It's smooth, it's continuous, and it is highly predictable.
It's the clockwork universe. Like you push a ball, it rolls, you know exactly where it's going to go.
Right. But the very moment you zoom in, down to the level of atoms or electrons or photons, you cross a border.
You enter the quantum realm.
You cross into quantum mechanics, the physics of the very small. And suddenly, all those smooth, predictable rules just completely evaporate.
They just stop working.
Entirely.
Yeah.
Things become probabilistic. Particles seem to exist in multiple states or locations at once until they are measured.
Right. Superposition.
Yeah, superposition.
Yeah.
They seemingly teleport. It's notoriously, well, weird.
Everyone calls it quantum weirdness.
Exactly. And the massive, glaring problem at the heart of science right now is that the math of the big and the math of the small fundamentally refuse to talk to each other.
They hate each other.
They really do. If you try to mash their equations together, the whole thing just breaks down into infinities and complete nonsense.
Which brings us to MIT, because recently these researchers at MIT tried to solve this century-old headache, didn't they?
They did. They proposed what they called a mathematical bridge to finally unite these two worlds.
Right.
They essentially put forward a framework to merge the quantum and the classical.
But Dukas, in this new paper, just absolutely dismantles it.
Oh, he takes it apart piece by piece.
He argues that MIT's bridge is built on a fundamentally flawed foundation. His overarching claim, which is just wild, is that all this quantum weirdness we've spent a century obsessing over...
It isn't actually weird at all.
Right. It's just incomplete. We've literally just been looking at the shadow.
What's fascinating here is how Dukas deconstructs the MIT approach. It's so revealing.
Yeah.
Because he doesn't just say MIT's math is sloppy. He says it is functionally blind to the true multidimensional architecture of reality.
Okay, so let's look at what MIT actually did. Let's break this down for everyone.
Right. They attempted to rewrite the famous Schrödinger equation.
Which is like the absolute bedrock formula of quantum mechanics, right?
Exactly. The bedrock.
Oh,
And they tried to rewrite it by supplementing it with a classical density field.
okay, wait, let me make sure I'm mapping this out right for us. For those of us who haven't looked at a physics whiteboard recently. Sure.
The formula MIT put forward is essentially this. Schrödinger's wave mechanics equals Hamilton-Jacobi plus a density variable.
That is the core of their proposition.
Right. And Hamilton-Jacobi, just to be clear, is a classic formulation of Newtonian mechanics, right?
Yes.
It's the math of pool balls hitting each other. So MIT is trying to map these crazy, unpredictable quantum probabilities into this smooth, classical, fluid-like framework by adding a specific variable for density.
Exactly.
I mean, on the surface, that sounds like a really elegant way to force the big and small to finally shake hands.
It is deeply elegant in its ambition. I mean, the thinking goes, look, maybe quantum particles aren't just these mysterious, ghostly probabilities.
Right. Maybe there's substance there.
Exactly. Maybe they flow and behave like a physical fluid, and we can prove it if we just add this spatial density field.
Which they denote mathematically as rho of x and t, right?
Yes, rho of x and t. They are really trying to give classical physical substance to these quantum ghosts.
But Dukas steps in and says this approach is structurally doomed. Doomed from the start.
He argues that MIT is relying on the completely wrong kind of density.
That's the crux of the first major failure that Dukas points out. MIT uses a spatial density.
Okay, spatial.
It's classical, it's fluid-like, and it's essentially non-dimensional in the way it handles space.
So, like, think of it like measuring the density of water flowing through a city pipe.
That's a perfect way to picture it. It describes how much physical stuff is occupying a specific volume of three-dimensional space at a specific ticking moment in time.
So wait, if MIT is just treating this density like a physical fluid moving through space, is that kind of like, I don't know, trying to measure the actual total volume of the ocean by only studying the ripples on the surface?
Oh, exactly.
Like you're tracking the movement left and right, the X and Y coordinates, but you are totally blind to the actual depth underneath the water.
That is a remarkably accurate way to visualize their limitation. You're watching the surface wave, you're mapping its coordinates, and you're assuming that 2D plane represents the entirety of the ocean's mechanics.
Just totally missing the deep water.
Right. MIT is purely looking at where things are in space. But Dukas introduces a concept that completely flips this entire paradigm on its head.
This is the temporal density thing, right?
Yes, something he calls temporal density. In his theory, in TDUFT, the fundamental behavior of the quantum universe isn't driven by spatial density at all.
Not at all.
No, it is driven by how time itself compresses.
Temporal density. Okay, so he writes this mathematically as rho sub t equals t squared times squared.
Time squared, yes.
I really want to pause and just chew on this for a minute because this is a massive conceptual leap for most of us.
It really is. It changes everything.
Because we are so conditioned to think of time as just, I don't know, a metronome.
Right, a clock on the wall.
Exactly. A
Yeah.
constant ticking clock in the background of reality. Tick-tock, tick-tock. Just a straight, unbending line that we walk down.
Passive stage.
Yeah.
Yeah.
But Dukas is talking about the density of time. He's saying time can actually pack together.
That's exactly what he's saying.
But how does time compress? I mean, what does a denser second even look like?
Well, think about the mechanics of that shift in perspective. If time is just a background parameter, just that passive stage upon which the universe performs, then things only happen in time.
Right.
But if time is a physical geometric operator that can become dense, then time is an active participant in reality.
Oh, wow.
In Dukas's framework, temporal density is literally the engine of the universe. When time compresses, when that temporal field becomes denser, it creates a geometric dimensional shift.
Okay, dimensional shift.
And that geometric shift is what actually produces mass.
Wait, hold on. You're saying mass, like the physical heft of a bowling ball, is just an emergent property of compressed time?
Exactly.
That is insane.
I know it sounds like science fiction, but mathematically it resolves so much. When temporal density increases, it manifests in our observable reality as what we call mass.
Wow.
Furthermore, this compression of time is what produces the curvature of gravity.
Oh, so it's not just mass, it's gravity too.
Right. It is what forces a quantum state to collapse from a mere possibility into a physical reality.
And MIT misses all of this.
MIT's spatial density can't do any of that because it lacks dimensional tiering. It's just a flat ledger of stuff moving around in a space that is already assumed to exist.
So they just leave the actual engine out Entirely.
Entirely.
This is genuinely staggering. So MIT built this incredibly intricate mathematical bridge to try and explain how the whole universe works, but they left out the fundamental building block that actually gives the universe its physical weight.
The distinction here is subtle, but it is catastrophic for MIT's theory. Dukas points out that MIT's bridge isn't completely 100% wrong in its mechanics.
It's not.
No, it's just unfinished. They stumble onto a fragment of the truth.
Okay.
And the really profound proof of this is that when you take MIT's equation and you mathematically complete it by ripping out their spatial density and inserting Dukas's temporal density,
What happens?
the entire MIT framework collapses perfectly into TDUFT.
Oh, wow. So MIT basically accidentally built the front porch of Dukas's house, dusted off their hands, and thought they had constructed the entire universe.
That's a great way to put it.
Yeah.
They built a beautiful porch, but they forgot the foundation, the walls, and the roof.
Right.
They have absolutely no mechanism for mass and no mechanism for gravity.
Okay, so MIT misses the mark on density because they are totally blind to time acting as this physical, compressible geometry.
Correct.
But according to Dukas, that is only half the problem, right?
Just half.
Even if they fixed their density issue, they are still fundamentally misinterpreting the actual waves of quantum mechanics.
Yes. The waves are the second huge stumbling block.
So if MIT is looking at the shadow on the screen, this next part is really about the light coming from the projector itself.
Absolutely. To fully understand this misinterpretation, we have to look really closely at the Greek letter psi.
Okay, psi.
In standard quantum mechanics and deeply embedded in MIT's bridge, psi is the universal symbol for the wave function.
Right, it's like the core of Schrödinger's math.
Exactly. Yeah. MIT defines it algebraically as a complex amplitude. Specifically, it involves the square root of their density times an exponential containing the imaginary number I.
Right, the imaginary number I, meaning it is mathematically unitless, it relies on imaginary numbers, and it operates exponentially.
Correct.
So just to translate that for the rest of us, psi isn't a physical thing you can touch.
No, not at all.
It's a probability curve. It's basically a math trick we use to guess where an electron might be before we actually look at it.
That is the standard interpretation, yes.
It's basically a purely symbolic representation of our own ignorance.
It's a ledger of probability, non-physical and non-geometric. But Dukas argues that this is the original sin of modern physics.
Original sin.
Yes. He says you simply cannot build a solid, physical, deterministic universe out of an imaginary math symbol.
That makes intuitive sense. You can't build a real house out of imaginary bricks.
Right. So TDUFT introduces a completely different paradigm, a dual real wave architecture.
Dual real waves.
He strips away the imaginary math entirely and replaces it with real physical dimensional waves. And crucially, there are two of them interacting,
Okay.
phi and psi.
Let's break these two waves down really slowly because I feel like this is where the paper fundamentally rewrites reality.
It really does. Let's start with phi.
Okay, phi, which Dukas calls the expansive wave.
Yes, the expansive wave. He describes it as being additive in its geometry. It possesses an outward curvature, and it operates in what he calls a lattice growth mode.
So it's building outward,
Right.
and then you have its inseparable partner, psi.
Right. But we have to note that Dukas's psi is completely different from the imaginary psi of standard quantum mechanics.
Right, the old probability curve. This
Yeah.
is a new psi,
Yes. In TDUFT, psi is the contractive wave.
the contractive wave.
It is multiplicative rather than additive in its wave dynamics. It possesses an inward curvature, and it is entirely responsible for the collapse mode of the universe.
Okay, I'm trying to visualize this. Standard physics looks at psi as just this math trick to calculate odds. But Dukas is saying no, these are literal physical waves of geometry. One expands, one contracts.
Exactly.
It's almost, it's biological. It's like breathing.
Oh, that's a good analogy.
Like phi is the inhale.
Yeah.
It's expanding the geometric lungs of the universe, pushing outward and building structure.
Yes.
And psi is the exhale.
Yeah.
Contracting, pulling inward, and collapsing all that geometry into the hard reality that we actually observe.
That is a phenomenal way to conceptualize the two interacting domains that Dukas outlines. Because you have the geometry domain, which is governed by addition phi plus psi.
The inhale.
Right. This domain is responsible for creating dimensional shells,
Yeah.
the outward curvature tiers, the actual scaffolding or lattice structure of space itself.
Okay.
And then you have the wave domain, which is governed by multiplication, phi times c psi.
The exhale.
Exactly. This domain creates torsion, interference patterns, dimensional emergence, and what we actually observe in experiments as quantum collapse.
And if I'm understanding this right, MIT just doesn't have phi at all. Like, it's completely absent from their math.
None whatsoever. It doesn't exist anywhere in their framework.
Wow.
They rely entirely on their symbolic, incomplete version of psi, and because they only have an incomplete wave domain, they have absolute zero geometry domain.
So if we use that breathing analogy, MIT is trying to write this comprehensive medical textbook on the breathing of the universe while completely ignoring the existence of the inhale.
Yes.
And simultaneously pretending the exhale is just some kind of statistical illusion.
It's wild when you put it like that. But mathematically, that's exactly what they're doing.
The philosophical implications of that are just staggering to me. Think about the last 100 years of science.
Oh, absolutely.
You have the smartest people who have ever lived on this planet, Einstein, Bohr, Heisenberg, and they are pulling their hair out over quantum weirdness.
Debating it endlessly.
Right. Why does a particle act like a wave sometimes? Why does it randomly lock into a single location when a human being looks at it? Does human consciousness create reality?
All those massive existential questions.
Yeah. And Dukos is basically stepping into that historic debate and saying, hey guys, you are confused because you are trying to describe a dual wave inhale-exhale universe using a single imaginary math symbol.
It is the ultimate relief of Occam's razor.
It really is.
Quantum mechanics isn't mysteriously weird, and particles aren't performing magic tricks for us. The weirdness is strictly an artifact of a severely limited mathematical vocabulary.
We just didn't have the words.
Right, when you try to project a dual real-wave geometry, this really complex interplay of expansion and contraction onto a single flat complex plane, which is what standard quantum physics forces us to do. Of course, it looks like bizarre magic.
Because you're missing half the physical information.
Exactly.
It's like trying to understand a wildly complex stereo audio recording, right? Like a full symphony.
Okay.
But you've only got the left speaker plugged in.
Right.
And you're sitting there scratching your head wondering why half the instruments sound like these ghostly whispers that pop in and out of existence for no logical reason.
That's brilliant.
You're blaming the music for being weird instead of realizing your equipment is fundamentally broken.
Exactly. Your equipment is broken.
Yeah.
And once you restore both phi and psi to the equations,
right.
Once you plug in that right speaker, the superposition we talked about earlier isn't magic anymore.
It makes sense.
It's just coherent projection across different physical tiers of this geometric lattice.
Wow.
And the infamous measurement problem, that mystical moment, a quantum possibility locks into a hard reality when observed.
Yeah, the cat in the box thing.
Right. It is no longer a paradox. It is simply the psi-driven wave contracting and collapsing onto a stable node of that geometric lattice.
Wait, okay, so if this dual wave dynamic, this continuous inhale and exhale of space itself, is what's actually happening out there, who or what is writing the sheet music for this cosmic breathing?
Right, the blueprint.
How do these waves know exactly how to interact? That brings us to what I think is easily the most intimidating, but also kind of the most beautiful part of the paper.
The universal master unification equation.
Yes. What Dukas presents as the literal blueprint of the universe.
This is the absolute core of TDUFT.
Right.
This is where Dukas really lays his cards on the table for everyone to see.
Okay, set it up for us.
He proposes a single covariant operator that governs what he calls the eternal fill lattice. Now, the equation itself is dense.
Very dense.
It requires a deep background in tensor calculus to fully unravel, but its structural implications are deeply, deeply profound.
Okay, I'm going to attempt to read this equation out loud, mostly just to get the architecture of it out in the air, and then I really need you to translate it for us.
Go for it.
Okay, here we go. The equation is the partial derivative with respect to tau of d to the power of n equals b superscript phi, nn plus delta, times v sub t times the gradient of L of d to the power of n minus delta, minus the natural log of phi times the gradient of s sub n times d to the power of n.
Perfect delivery. And I know that sounds like absolute alphabet soup to the uninitiated, but let's break down what it physically represents.
Please do.
Imagine the equation as a perfectly balanced scale. On the left side of the equal sign, you have that partial derivative with respect to tau.
Right.
In really simple terms, this is tracking how the dimensional structure of the universe changes specifically as time moves forward.
Okay, so the left side is the universe changing over time.
Yes. Now, look at the right side of the equal sign. It splits into two distinct halves, separated by a minus sign.
Okay, so two competing forces on the right side. Let's look at the first half of that right side.
The first half of that expression is the expansive induction current.
The expansive induction current.
Yes, this is the geometry side. Of the phi-driven side we discussed earlier, the inhale.
Okay, got it.
It describes the outward additive growth of the spatial lattice. And what's absolutely fascinating here is that this left-hand portion is the only part that MIT accidentally managed to capture with their Hamilton-Jacobi density addition.
Wait, really? Let me get this straight. MIT's Grand Unified Bridge basically only mapped out the left half of the universe's blueprint.
Precisely. They mathematically described the expansion, the growth.
But they totally missed the second half.
They completely missed the second half of the equation.
Yeah,
That crucial term started with the minus natural log of phi.
Okay, what is that half doing?
This right-hand side is the entropy gradient.
The entropy gradient.
And it is entirely 100% missing from MIT's bridge. And this entropy gradient is not just some minor mathematical detail. It is the mechanism that governs time asymmetry.
Which means?
The arrow of time. The fact that time goes forward and not backward.
Oh, wow.
It also governs the contractive collapse of waves and dimensional descent.
So basically, MIT's math allows for a universe to expand and grow outward forever, but it completely lacks any mechanism for anything to ever settle down into a permanent physical state.
Exactly.
Without the entropy gradient, time doesn't even move in a single direction in their model.
Right, there's no arrow.
They have no mechanism for gravity to pull things together, no mechanism for mass to actually emerge. It's basically a universe stuck on pause, just inflating endlessly into nothing.
Without that entropy term, you do not have reality as human beings experience.
Right.
But with it, when you balance the expansive induction current with the contractive entropy gradient in this single master equation, Dukas demonstrates something miraculous.
Miraculous is a strong word for physics.
Well, he claims you can mathematically derive everything.
Everything.
From this one formula, he derives all 25 fundamental particles of the standard model and their exact masses.
Seriously.
He derives the precise value of the speed of light. He derives the exact mechanism of gravity. And most importantly, there are no free parameters, no landscape tuning.
Okay, I have to jump in here because that is a massive direct shot across the bow at standard model physics and string theory.
Oh, it's a direct hit.
Because right now, the way physics works, scientists literally have to manually plug in dozens of constants, like the mass of an electron or the strength of gravity or the speed of light, just to make their equations function.
Right, they have to hard code the universe.
Yeah, they call them free parameters, which has always struck me as a really polite academic way of saying, well, we have absolutely no idea why this number is what it is, but if we don't type it into the calculator, the whole universe breaks.
It is the glaring fudge factor problem of modern science. Standard physics has to constantly fine-tune the universe by hand to make the math match what we actually see in telescopes and microscopes.
Right.
But TDUFT says that entire approach is nonsense. The universe is not a machine with dozens of random dials that some creator had to arbitrarily tune to exactly the right decimal point.
So where did the numbers come from in TDUFT?
TDUFT argues that everything emerges deterministically from one single underlying mathematical constant.
One constant.
And that constant is phi, the golden ratio.
All right, I have to play the skeptic here, because this is where my alarm bells really start ringing.
I don't blame you.
We usually associate the golden ratio, which is an irrational number roughly equal to 1.618, with, frankly, softer sciences or biology or art history.
Right, the Fibonacci sequence.
Exactly. We see it in the spiral of pine cones, the arrangement of sunflower seeds, nautilus shells, the proportions of the Mona Lisa.
It's famously everywhere in nature.
Right. It's an aesthetic of nature. It is beautiful. But Dukas is saying it's the literal skeletal structure of the quantum vacuum. I mean, isn't that bordering on numerology? Physicists usually hate that kind of thing.
They absolutely hate it.
So why would the cold, hard, fundamental universe prefer the golden ratio over, say, pi, or just a simple whole number like 2? Are we really saying the universe uses the same math as a spiral staircase?
It is a completely valid reaction to be skeptical about this, because it sounds almost mystical on its face.
It does.
But the answer Dukas provides is grounded in brutal, uncompromising number theory. It has absolutely nothing to do with aesthetics or beauty.
Okay, then what is it about?
It is entirely about mathematical stability. Mathematically speaking, the golden ratio, phi, is the most irrational number that exists.
Wait, I need you to explain that. What does it mean to be the most irrational?
Right, it sounds like an oxymoron.
Yeah, aren't all irrational numbers, like pi or the square root of 2, aren't they equally irrational? They all go on forever without repeating, right?
They do all go on forever, but they are not equally irrational. In number theory, an irrational number is one that cannot be expressed as a simple fraction like 34 or 58.
Right.
But some irrational numbers can be approximated by fractions much more easily than others.
Okay.
If you look at the continued fraction representation of the golden ratio, it is made entirely of ones. Just ones.
Oh, weird.
It is the slowest converging continued fraction possible, meaning phi is the absolute hardest number in existence to approximate using rational fractions.
So it fiercely resists being rounded off.
Exactly. Because of this extreme, uncompromising irrationality, it is the absolute best number for creating structural stability in what physicists call quasi-periodic systems.
Okay, you've used that term before, quasi-periodic systems. What exactly is a quasi-periodic system, and why does the universe need to be one?
Imagine you are a tile setter, okay, and you are trying to cover an infinite floor.
Okay, infinite tile job. Got it.
If you use simple, rational geometric shapes like squares or regular hexagons, they repeat perfectly over and over. That pattern is periodic.
Right, like a checkerboard.
Exactly. But the problem with perfectly repeating patterns is that they are highly susceptible to destructive interference.
Destructive interference.
Yeah. If a wave of energy passes through a perfectly periodic lattice, it can easily build up resonance and shatter the structure.
Oh, like a singer hitting the right note to shatter a wine glass?
Yes, exactly like that. The resonance builds up because the pattern repeats exactly. Now, if you try to build a complex, multidimensional lattice that never exactly repeats itself, but still maintains a uniform, unbreakable structure.
That's a quasi-periodic lattice.
Exactly. And to build that, you need a specific mathematical scaling factor that prevents the patterns from collapsing in on themselves or resonating destructively.
And that factor is the golden ratio.
Because phi is the most irrational number, it prevents those destructive harmonic overlaps. It allows for infinite stable growth without the structural fabric tearing itself apart.
That is wild.
The universe uses the phi lattice because it is the only geometric structure capable of supporting the infinite complexities of reality without mathematically degrading into chaos.
Oh, okay. My mind is genuinely blown right now. So nature uses the golden ratio in sunflowers so the seeds pack together perfectly without wasting space.
Right.
But the fundamental universe uses the golden ratio to pack dimensions together without the entire fabric of reality shredding itself to pieces.
Beautifully put.
It's basically the ultimate shock absorber for reality.
That is precisely what it is. And Dukas calls this mechanism dimensional resonance.
Dimensional resonance.
Think about how standard quantum physicists describe particle behavior. They observe particles making discrete quantum jumps, teleporting instantaneously from one energy state to another without existing in the space between.
Okay, this is literally where the pop culture phrase quantum leap comes from.
Exactly. Standard physics says this is just a weird, magical property of nature.
The particle is just blinking out of existence and reappearing somewhere else.
Right. But in TDUFT, those jumps, which correspond to integer multiples of Planck's constant, aren't random magic.
What are they?
Dukas mathematically maps these jumps and shows they correspond perfectly to tier crossings on this underlying lattice.
So let me try to visualize this. It's like an elevator moving up a skyscraper. But instead of the floors being equally spaced 10 feet apart, the distance between the floors is scaled by the golden ratio.
Yes,
The
perfectly.
particle isn't teleporting magically through walls, it's just physically moving from one hard geometric rung of the phi lattice to the next.
Yes. The quantization of nature, the fact that the universe operates like a staircase rather than a smooth ramp, is simply the discrete, physical structure of the phi lattice revealing itself to our instruments.
That is so deeply satisfying.
The universe isn't built on a smooth void of empty space. It's built on a rigid, golden ratio scaffolding.
Okay, this brings up a massive contradiction that I really feel like we need to address.
Let's hear it.
If this master equation is truly this elegant, if it derives the exact speed of light, if it explains mass without using arbitrary fudge factors, and if it completely removes all the weirdness of quantum mechanics by giving it a physical geometric structure,
Right.
why in the world has the scientific community been completely obsessed with Schrödinger's equation for a century?
It's a great question.
Why has everyone, including the absolute geniuses at MIT, been stubbornly staring at the 2D shadow instead of turning around to look at the projector?
That question brings us to one of Dukas's boldest and most controversial claims in the entire paper. He argues that physicists have been caught in what he calls a domain trap.
A domain trap.
He asserts that Schrödinger's equation, despite its fame and usefulness, is mathematically quarantined.
Okay, explain this trap. How is a mathematical formula quarantined?
The standard Schrödinger equation is undeniably brilliant for what it does, but Dukas argues it categorically does not and cannot describe physical three-dimensional reality.
It can't.
No, it mathematically describes a two-dimensional charged surface domain.
Okay, going back to our opening analogy.
Exactly. Schrödinger's equation is the literal mathematics of the 2D movie screen. It cannot comprehend the 3D space of the theater.
So the absolute bedrock equation of modern physics is literally missing a spatial dimension.
Mathematically, yes, it is.
How does he prove that?
Dukas proves this through a very specific dimensional relation. He outlines the equation. D squared equals D cubed times the absolute value of C die.
D squared meaning 2D and D cubed meaning 3D.
Right. And what this single line of algebraic truth does is mathematically confine the Laplacian operator strictly to the surface domain.
Okay, let's slow down and translate that. The Laplacian operator, which in the math is denoted as an upside-down triangle squared over 2 meters, right?
That's the one.
What does that operator actually do in Schrödinger's equation?
In the simplest terms, the Laplacian operator is the part of the equation that calculates how a wave spreads out and curves through space. It calculates spatial curvature.
But Dukas is proving that this specific operator, the beating heart of Schrödinger's math, is structurally locked into calculating the curvature of a 2D surface.
Yes, like a wave moving across a flat pond.
It cannot mathematically reach up into a 3D volume.
It's mathematically trapped.
So, if I'm understanding the implication here,
Yeah.
trying to use Schrödinger to understand gravity, which obviously requires mass, which obviously requires 3 spatial dimensions, plus the temporal density we talked about earlier.
Right.
It's like trying to use the rules of chess to play a game of tennis.
Oh, that's exactly it.
You are fundamentally on the wrong dimensional playing field.
The chess and tennis analogy is perfect. And if you follow this logic down to the bedrock, it explains why Schrödinger's equation has been historically both incredibly successful and incredibly frustrating.
Because it works for some things, but not others.
Exactly. It works flawlessly for describing photon propagation and the spectral lines of atoms.
Why?
Because, as Dukas points out, photons and spectral charge lines actually live in the d-squared domain.
Oh, they are 2D phenomena.
Are literally surface phenomena. Schrödinger is the undisputed king of the d-squared realm, which is why it has survived for a century.
But the very second you ask Schrödinger, hey, what about gravity? What about a bowling ball falling to the Earth? What about planetary orbits?
The math completely breaks down and spits out infinities.
Because gravity and mass exist in higher dimensional domains?
Yes, d cubed for volume and d fourth for force. Schrödinger's wave function is basically just a highly sophisticated collision-counting artifact.
A ledger?
It's a ledger tracking elastic interactions on a flat 2D surface. It's what physicists call an effective theory.
Effective meaning it works for one specific thing.
It effectively describes what's happening at a specific, highly limited scale, but it is structurally useless for true unification.
Which makes the flaw in MIT's approach so glaringly obvious now.
Doesn't it?
MIT tried to add a density field to the Schrödinger equation. They tried to graft a 3D classical fluid onto a 2D mathematical operator.
Exactly. As Dukas ruthlessly points out, adding a spatial density variable to a 2D operator still leaves you trapped in 2D.
Can't just slap it on there.
The spatial density variable simply inherits the dimensional limitations of the operator it's attached to. You cannot escape the movie screen just by painting more 2D shadows onto it.
You're still just mixing colors on the flat canvas. You haven't magically turned the canvas into a 3D marble sculpture.
And that is why Dukas states so emphatically that true unification requires moving completely beyond the Schrödinger formalism.
You cannot patch a shadow.
No, you have to turn around and look at the actual phi lattice projecting it.
It is just staggering to think about the sheer amount of intellectual capital, you know? The decades of brilliant minds and billions of dollars in research grants that have been poured into trying to force gravity into Schrödinger's tiny 2D box.
It's a sobering thought for the field of physics.
But the thing is, Dukas isn't just taking a sledgehammer to quantum mechanics. He argues that we also have to completely rethink classical Newtonian physics if we want to achieve true unification.
Right, because if the goal of unification is bringing the big and the small together into one framework, you can't just fix the math of the small.
Right.
You have to demonstrate that the classical world is governed by the exact same underlying geometric rules.
And this is where Dukas tackles classical orbital mechanics.
Yes.
This part of the paper really threw me for a loop. We're talking about planets orbiting stars.
Right.
Johannes Kepler figured out the laws of planetary motion centuries ago. Newton gave us the gravitational math. I always thought orbital mechanics was the most solved, indisputable problem in the history of physics.
Most people do.
What is there to rethink?
Well, functionally, for the purposes of launching a satellite, it is solved.
Okay, good. Satellites still work.
Right. But ontologically meaning, what is physically causing the orbit Dukas completely reinterprets it.
How so?
He examines his own third law in its original geometric form, which states t squared equals phi cubed times r sub phi cubed.
Okay, let's unpack that formula. T is the orbital period, like how long it takes a planet like Earth to go all the way around its star.
Correct.
And Dukas is saying that period squared is proportional to the golden ratio cubed multiplied by the phi-scaled orbital radius cubed.
That's the geometric version. But Dukas does something mathematically brilliant to directly counter the MIT team.
What does he do?
He reformulates this geometric law purely into a density law.
Oh, to fight them on their own turf.
Exactly. He introduces temporal density and phi lattice density, and the equation evolves into t squared times rho suborbit equals k sub phi times m.
Okay, break that down for me in plain English.
It means that the orbital period squared multiplied by the orbital mass density equals a phi-dependent mathematical constant times the mass of the central star.
Okay.
What he is doing here is redefining orbital density as mass distributed over a phi-scale volume.
Wow.
He mathematically proves that planetary orbits are not just inert rocks moving through a vacuum of empty space. They are physically governed by the density of the phi lattice and the density of time itself.
So even a massive classical system like the Earth going around the sun is actually surfing on this golden ratio geometric lattice.
Yeah.
It is governed by temporal density, not a classical spatial fluid.
Think about the implications for MIT here.
Oh, man.
If MIT's idea of a spatial density field, the water in a pipe, can't even correctly describe the fundamental physical nature of a classical planetary orbit.
How could it possibly be the bridge to unify classical mechanics with the complexities of quantum mechanics?
Exactly.
Right. If your bridge can't even hold up a bicycle, how's it going to hold up a freight train?
It's not.
So, to synthesize this, it sounds to me like MIT brought a ruler to measure the speed of light. Dukas is pointing out that classical mechanics planets orbiting and quantum mechanics particles collapsing are actually speaking the exact same fundamental language.
The exact same.
They are both driven by the language of temporal density and the geometry of phi lattices.
Right.
MIT just chose the wrong dialect by trying to force everything into a spatial fluid.
That's a perfect synthesis. Classical mechanics and quantum mechanics aren't two different realities. They are just two different projections of the exact same underlying phi lattice.
It all comes back to the lattice.
True unification isn't about algebraic equivalence. It is about dimensional resonance across that lattice.
Okay. I am totally on board with the math. It is incredibly beautiful.
It really is.
The idea of a dual-wave breathing universe built on the golden ratio where time literally compresses to create mass, it's deeply poetic.
It is.
But physics isn't poetry. It demands hard empirical proof.
It absolutely does.
Does the real physical universe actually behave this way when we put it to the test in a laboratory?
That is the ultimate crucible for any theory. And Dukas knows it.
Good.
He dedicates a substantial part of TDUFT to empirical evidence. Because if there really is a geometric scaffolding to space, an active medium, an ether of sorts, we should be able to detect its subtle physical influences on our instruments.
Wait. I know Einstein supposedly put the final nail in the coffin of the ether theory back in the early 20th century.
He did?
Standard physics says space is a vacuum. So if Dukas is bringing back the idea of an invisible space fluid that light travels through, he must have some bulletproof physical evidence.
He does.
What is he looking at that everyone else missed for 100 years? Is standard physics actually going to accept this?
It's a crucial distinction we have to make first. TDUFT does not resurrect the rigid, static, classical ether of the 1800s.
Okay.
That version of the ether was empirically disproven. The old idea was that the ether was a stationary fluid that the universe dragged through.
Right, like driving a car through the rain.
Dukas is describing something entirely different. A dynamic, fractal, phi-anchored lattice that co-moves with local temporal density fields.
It co-moves. Okay.
It's not a stagnant fluid. It is an active geometry. And he points to 3 specific, highly documented experiments to prove it.
Let's dig into the first one. The Brillat Hall anomaly from 1979.
Right.
Set the stage for me. What was this experiment and what did they actually find?
Well, Elaine Brillat and John Hall were conducting an incredibly precise experiment in Colorado. They set up a highly sensitive laser interferometer on a continuously rotating table.
Okay, laser on a spinning table.
Their goal was to look for any microscopic anisotropy in the speed of light.
Anisotropy meaning checking if light travels slightly faster or slower depending on which direction it's pointing in space.
Yes.
Like, does it travel faster pointing north versus east?
Precisely. According to standard Einsteinian relativity, the speed of light is perfectly constant in all directions. No variations whatsoever. A pure, absolute constant.
But they did find a variation, didn't they?
They did. They found a tiny but highly persistent variation. An anomaly of about 1 part in 10 to the 15th.
That's tiny.
It is, but crucially, this variation wasn't just random jitter. It had a clear, repeating 2 omega harmonic dependence as the apparatus rotated.
So it was rhythmic.
Yes, it was a very specific rhythmic wobble in the speed of light.
And how did the mainstream physics community react to this wobble?
They largely dismissed it as systemic noise. Instrumental error.
Really? Just swept it under the rug?
When an anomaly directly contradicts a fundamental pillar like standard relativity, the conservative assumption is usually that the machine was slightly off or there was thermal expansion in the room.
But Dukas looks at this data and says it wasn't noise at all.
Dukas proves it wasn't noise. In TDUFT, this exact signal is mathematically predicted.
How?
Remember the contractive wave we discussed? Psi-A.
The exhale.
Right. Dukas calculates that a massive body like the Earth acts as a rotating side of the 4th planetary contraction node.
Okay, explain how a contraction node physically affects space. What is it doing to the lattice? Does it pull it like fabric? Does it spin it like a whirlpool?
Think of it like a dense knot in a fishing net. Because Earth is a massive temporal density well, it physically grips and twists the phi lattice as the planet rotates.
It twists the space around it.
It pulls the geometric fabric inward and spins it. And TDUFT's equations predict that this precise twisting will cause a microscopic directional variation in the speed of light.
And does the math match the experiment?
Perfectly. It predicts the exact amplitude and the exact quadrupolar 2 omega rhythmic signature that Brillat and Hall actually detected.
That is wild. The physical data has just been sitting there since 1979, but we just ignored it because we didn't have the math to understand it.
Exactly. We called it noise because we had no framework for twisting space.
Standard physics had no theoretical framework to accommodate a twisting space, but TDUFT predicts it perfectly as a fundamental feature of the lattice.
It's built in.
Okay, but what about the historical experiments that didn't find anything? Like the famous Kennedy-Thorndike experiment in 1932.
Ah, yes.
Standard physics uses its null result, the fact that they found 0 variation in the speed of light, as the absolute definitive proof that no ether or lattice exists. How does Dukas deal with that?
This is where understanding the dynamic nature of the lattice is absolutely key. Kennedy-Thorndike was designed specifically to test if the Earth was moving through a rigid, stationary ether.
Right.
The logic was, if space is a rigid grid, the speed of light should appear to change depending on the Earth's velocity as it flies around the sun.
And they found a null result, 0 change.
Which seemingly proved Einstein right once and for all, no ether, empty space.
You'd think so.
But the math of TDUFT reveals that a null result is actually exactly what you would expect from a dynamic lattice.
But why?
The phi lattice isn't a fixed grid that the Earth flies through like a bird flying through the air. The lattice is temporally anchored to mass.
Temporally anchored.
The Earth's massive temporal density field physically grips and pulls the local lattice with it, stabilizing it in the local reference frame.
Ah, I see. So it's more like a spider walking on its own web, dragging the web with it, rather than a bird flying through independent air.
That's a great visualization. Furthermore, TDUFT's speed of light equation includes temporal density and harmonic attenuation terms that dynamically compensate for directional variations.
So it fixes itself.
The lattice actively adjusts locally to maintain equilibrium. So, a null result in 1932 doesn't prove there is no lattice.
It simply proves the lattice isn't a rigid classical object.
Exactly. It perfectly aligns with TDUFT's concept of dynamic temporal anchoring.
It's like checking to see if a glass is full of water by turning it upside down. If nothing falls out, you might loudly declare, the glass is completely empty.
Right.
But TDUFT is stepping in and saying, no, the water is frozen into ice. It's firmly attached to the glass. It's still there. It's just structured differently than your test assumed.
Exactly. The lattice responds to mass. It isn't an inert background.
Which brings us to the third, and I think most jaw-dropping piece of empirical evidence in the paper, the Technion bright-squeezed vacuum experiment.
This one is...
This sounds like something out of a science fiction novel. Trillion photon pulses emerging from a vacuum. What exactly is happening here?
This is perhaps the most striking, undeniable confirmation of Ducas's theory. Recent cutting-edge measurements at the Technion Institute involve looking at a pure laboratory-grade vacuum.
Empty space.
Empty space, shielded from all radiation, with a zero average electric field. According to classical physics, nothing should be there.
Right.
But they observed massive bursts of spontaneous energy, 27 femtosecond pulses of trillions of photons simply erupting out of the vacuum.
Standard physics says a vacuum is empty, a void. How can trillions of photons just burst out of nothing? Where is the energy coming from?
Standard quantum mechanics tries to patch this by evoking quantum fluctuations or virtual particles popping in and out of existence.
Which sounds like magic again.
It does. An MIT spatial density framework categorically cannot account for a vacuum that actively releases this massive scale of highly structured macroscopic energy.
But in TDUFT?
In TDUFT, the vacuum is not empty. It never was. It is a highly structured geometric medium, the phi lattice reservoir.
Ducas calls it D10 vacuum magnetism, right? How does that work?
The math states D10 equals psi squared density times d cubed volume.
Okay.
In simple terms, the vacuum of space is brimming with intense magnetic geometric energy stored in the contractive psi waves of the lattice.
The stored energy of the exhale.
Exactly. What Technion actually measure, those intense 27 femtosecond pulses, perfectly matches TDUFT's exact predicted timescale for a specific torsion transition on the lattice.
The torsion transition.
A moment where a d-squared surface domain violently snaps into a d-cubed spatial volume.
So they basically caught the lattice exhaling.
They did.
They caught the invisible dimensional structure of space physically releasing stored energy as it shifted gears from 2D to 3D.
They captured the active geometric medium of reality in action.
That is just wow.
This demonstrates unequivocally that the vacuum is not inert. It is a structured, dynamic reservoir of colossal energy.
Which is a clear empirical signature of the dual-wave architecture that TDUFT proposes.
It is. And it completely invalidates the old paradigm that reality is just particles floating in a dead, empty void.
We have covered an immense, almost overwhelming amount of intellectual ground today.
We really have.
For you listening, let's take a collective breath and just synthesize this entire journey.
Good idea.
We started by looking at a very noble, highly publicized attempt by MIT to build a bridge. They wanted to unite the classical world of falling apples with the quantum world of teleporting particles by adding a spatial density field to the Schrödinger equation.
Right.
But through the rigorous lens of George James Ducas's 2026 paper, we discovered that MIT basically brought a bucket of water to a geometric construction site.
They entirely missed the absolute necessity of time acting as a physical substance, temporal density.
Time packing together.
Exactly. They treated the universe like a classical fluid sloshing around in space, instead of realizing that mass and gravity emerge from the geometry of compressing time.
Right.
And more deeply, they remained stubbornly trapped in the two-dimensional shadow world of Schrödinger's math.
Missing the 3D reality.
Completely ignoring the physical dual-wave breathing of the universe. The expansive phi wave building the lattice and the contractive psi wave collapsing reality onto it.
TDUFT steps in, taps us on the shoulder, and says, look at the projector, not the screen.
Turn around.
It replaces the weird probabilistic casino of standard quantum mechanics with a single deterministic blueprint.
An infinite fractal lattice.
Built mathematically on the extreme irrationality of the golden ratio, where particles don't mysteriously teleport by magic, but logically jump across the dimensional tiers of the lattice. And this isn't just elegant whiteboard theory. It fundamentally reinterprets classical planetary orbits. It perfectly explains the ignored Brillat-Hall speed of light anomaly from 1979, and beautifully accounts for the massive photon bursts observed erupting from the vacuum at Tech 9.
The core takeaway here is a profound, necessary shift in human perspective.
It changes everything.
Quantum mechanics was never truly mysterious. It didn't require us to believe in magic or paradoxes or that the moon isn't there when we aren't looking at it.
Right.
It was just an incomplete mathematical projection. Reality, as Duke forcefully shows, is a self-referential harmonic projection on an infinite lattice.
The universe isn't a random roll of the dice. It is a perfectly tuned, dynamic, geometric instrument.
Beautifully said.
Which leaves us with a genuinely staggering final thought. If our entire understanding of quantum physics, literally the smartest minds of a century, billions of dollars, and countless textbooks, was just studying a 2D shadow of a multidimensional fractal lattice,
What else are we missing?
what else are we wildly misinterpreting? If the vacuum of space isn't an empty void, but is actually a structured, active medium brimming with D10 magnetic energy, could this golden ratio for lattice hold the key to understanding other massive cosmic mysteries, like dark energy?
It certainly could.
Or perhaps could it even explain the fundamental mechanism of human consciousness itself? Are our minds, our very thoughts, just another harmonic resonance echoing across the golden lattice?
Now that is a profound question.
It's something deep to chew on as you go about your week. Look closely at the shadows around you. We will catch you on the next deep dive.